In this section, we'll be going over the Capture-Recapture method, as well as some other vocab terms to finish up the chapter that deal with starting an experiment or starting a study. The Capture-Recapture method can be really helpful when we have no way of actually counting all the individuals of a certain population or a certain area. Specifically, maybe when we're looking at animal examples where you can't go around and capture, for example, every zebra in a certain part of a savanna. So you take a sample instead and use that to estimate what the total population would be. So the first step to this is we're going to capture or choose a sample of size n, and we'll tag all the individuals in that sample. So we'll mark them somehow so that we know that they're in the sample, and release them back into the general population. After that, after step 2, after a certain period of time, we're going to capture a new sample and take an exact head count of the tagged individuals. Let's call this number k. So when we take that new sample, we may get some of the original sample back in this new capture, and we may get some individuals that were not in the original sample. So here's an example to go along with it. We have small fish in a big pond. So we're looking at a large pond. It's stocked with catfish, and as a part of a research project, we want to estimate the number of catfish in the pond. Now, we can't just jump in the pond and go around and count all the catfish or attempt to catch them all. That would take too long, and it's nearly impossible to do. So what we want to try to do is use this to estimate. Step 1, for our first sample, we capture a predetermined number n of or n1 of catfish, saying n1 equals 200. Okay. The fish are tagged and released unharmed back into the pond. So we capture 200 fish, we tag them or mark them so that we will be able to tell in our next sample if we got any of the original from the first sample. Step 2, after giving enough time for the fish to disperse and get mixed back around in the pond, we capture a second sample, N2. Now, while N2 does not have to equal N1 exactly, it's a good idea for them to be almost the same. So maybe this time we capture 250. Of the 250 in that second sample, let's say that 35 have tags, so they were a part of that first sample we collected, and the others are new fish. And here's the little bit of math that finally goes into this. So the ratio of the tagged fish in the second example is the same as the ratio of the tagged fish in the pond. And the way this is typed out, or maybe the way it came in from the PowerPoint, everything's not showing up super well, so I'm going to write this out. So this should say the 35 out of the 250 that were originally tagged, okay, is equal to the original amount captured out of the entire pond. So that's kind of like saying K out of N2 should be relatively equal to N1 out of N, the total population. So we set up a proportion. So 35 out of 250 is equal to 200 out of N. And with proportions, there's just two steps. You can cross multiply and divide. So we'll say 250 times 200 right here, and then divide that number by 35. And we'll get about 1,428.57. And so it's sensible in the end to say, okay, well, if 35 out of our second sample, 250, if that's how many were tagged, well, we think the 200 we originally collected was a sample out of maybe a total of about 1,400 catfish, maybe give or take 100 or so. Now to finish out the chapter, I'm just going to go over a few more vocab terms when it comes to doing a study, trial, or experiment. So the first two here are clinical study or trial and confounding variables. So a clinical study is just a study that's concerned with determining whether a single variable or treatment can cause a certain effect. So maybe testing a certain type of medicine, for example. And confounding variables are all other possible contributing causes that could produce the same effect in a clinical study. So in a controlled study, the subjects are usually divided into two different groups. So we have the treatment group, where subjects are actually receiving the treatment, and the control group that are not receiving any treatment. And depending on the study, sometimes the groups may or may not know, or sometimes the subjects may or may not know which group they're actually in. So, for example, if there was a company who wanted to test a new medication for a pain reliever, they get a group of people who volunteer to do it, and they'd split one group and give them the actual medicine and give the other group either nothing or maybe a placebo, so just a fake medicine. In any kind of study, randomization is, of course, very important. So the subjects are assigned to the treatment group or the control group randomly. And as just mentioned in the last slide, the placebo effect, this is very critical. It's a confounding variable from the generally accepted principle that just the idea that one is getting a treatment can produce positive results sometimes. So if I'm in the treatment group receiving some kind of pain reliever medication, maybe it's working, maybe it's not, and or if I'm in the control group and I don't know it, and I'm taking this medicine that's maybe just a sugar pill. Sometimes you can kind of trick yourself into thinking, well, because I've taken this medicine, I'm feeling better. Whereas maybe your body is just starting to feel better by itself. So once again, to reiterate, so the placebo effect is the effect from being part of the fake treatment or the control group and not knowing it. And a placebo itself is any make-believe form of a treatment. So harmless pill, like a sugar pill, or an injection of saline solution, or any other kind of fake type treatment intended to look like the real thing. And a controlled placebo study is a controlled study in which the subjects in the control group are given a placebo. So pretty much the example I was just talking about. A blind study. This is a study in which neither the members of the treatment group nor the members of the control group know which of the two groups they belong. And this is usually a pretty good practice. We don't want people to know which group they're in. It tends to produce better results. And then in a double-blind study, this is a controlled placebo study in which neither the subjects nor even the scientists conducting the experiment know which subjects are in the treatment group and which are in the control group.